Today we will be doing tables of equivalent ratios. Okay, let's take a look at this problem and we are going to create a table in order to help us solve it. Okay, Maya's ice cream machine makes 4 cups of ice cream from half a cup of sugar. How many cups of ice cream can be made with 5 cups of sugar? Okay, so we need cups of sugar and total ice cream. Okay, I'm going to do I for ice cream and S for sugar. All right, and so it says 4 cups of ice cream can be made from half a cup of sugar. So if I have 4 cups of ice cream for 0.5 cups of sugar. What that means is then for 1 cup of sugar, all right, so I take 0.5 and I multiply it by 2 to get 1 whole. So if I have 1 whole cup of sugar, that's going to make me 8 cups of ice cream. Okay, do you guys see that relationship there? Okay, if 0.5 is 1/2, all right, and it takes 2 of those to create 1 whole, all right, we have 8 cups of ice cream. All right, again, I multiplied by 2 to get my 1, so 4 times 2 equals 8. Now I can continue to do that same exact process. Okay, 1 times 2, get 2. So we can, 1 times 2 is 2, 8 times 2 is 16, okay? And then I can also, each 1 cup of sugar I add, I'm adding 4 or 8 cups of ice cream. So if I add 1 more cup here, I would add 8 cups of ice cream here. So we would do 24 cups. Okay, we could also go from 1 to 3 directly by multiplying by 5. Okay, 1 times 3, or sorry, by 3. 1 times 3 is 3. And then 8 times 3 is 24. All right, and where I was going with that last thought is 1 times 5 is 5, which means 8 times 5 would give me the total number of 40 cups of ice cream for 5 cups of sugar. So making this table allows us to figure out, and we call it scaling up because we're multiplying to find bigger numbers in order to find our solution. I also want you to recognize that these are equivalent ratios. So it is, the ice cream is 8 cups of ice cream for 1 cup of sugar, which is equivalent to 16 cups of ice cream for 2 cups of sugar, and 40 cups of ice cream for 5 cups of sugar. Those are equivalent ratios and equivalent fractions, same thing. We're using the table to help us with those. Okay, so again, 40 cups of ice cream can be made from 5 cups of sugar. Okay, let's take a look at one more together. Okay, and this second one is very similar with that half a cup. Okay, we're gonna come down and look at number 3 here. Nicholas is having a birthday party. 3 small cakes serve 9 people. How many cakes should he order to serve 27 guests at the party? Okay, so we've got cakes and we've got people is going to be our table here. The number of cakes is 3, and that serves 9 people. Okay, well, if I have, let's multiply this by 2. I have 6 cakes. Okay, well, then I would multiply this by 2. That would serve 18 people. Okay, and if I go up one more time, I have 9 cakes. 3, 6, 9, 9, 18, 27. Oh, and look, the number of people at the party is what we're looking for, 27. So that means for 27 guests, we would need 9 cakes. All right, and number 4 is very similar to that one as well. I'm going to do one more together here. Lydia's having a barbecue. 2 containers of juice serve 10 people. How many containers of juice should she get to serve 40 people? So again, we have containers, or actually we have juice and we have people. All right. 10 people is 2 containers of juice. Okay. And 20 people is going to be 4 containers. Again, 10. We're adding, for every 10 people, we need 2 more containers. So if we have 30 people, we're going to need 6 containers. For 40 people, which is what we're looking for, we are going to need 8 containers. All right, we could also do 1 times 4 here, which would be 2 times 4, which would give us our 8 containers we were looking for there. Okay, so 2 different ways that you can use these tables to help. Okay, now a little bit of a different type of problem is right here. Jen can jump rope 80 times in 60 seconds. If she jumps at a constant ratio of seconds to jumps, how many jumps can she make in 15? So this time, we're going from a larger number, 60 seconds, to a smaller number, 15. So this is going to be called scaling down. Okay, so she jumps rope, and how many seconds? All right, so she jumps 80 times in 60 seconds. All right, so the way I would do this is if I'm trying to figure out, okay, I could scale down and I could do half of that, right? If I divide by 2, that would give me, for 30 seconds, they would jump 40 times. Okay, well then half of 30 is 15. So half of 20 then would be, or half of 40 is 20. So in 15 seconds, she's jumping 20 times. Okay, another way to do that is you could go directly to this 15 and say, okay, 60 divided by what equals the 15 seconds I'm looking for? Okay, well, 60 divided by 4 equals 15. So I would do 80 divided by 4 in order to find my 20 jumps. Okay, all right, and there are 2 more you can try that are similar to that. Okay, we'll do one more scaling down example together. A recipe for pasta noodles calls for 12 eggs for every 8 cups of flour. So we've got noodles and we've got flour. All right. Oh, no, we got eggs and we got flour. Sorry. Eggs. All right. And we need 12 eggs for 8 cups of flour. How many eggs are needed when 2 cups of flour are used? So I'm going to go directly to my 2. 8 divided by 4 equals 2. So I'm going to do 12 divided by 4. And that is going to be 3. So I'm going to need 3 eggs with my 2 cups of flour. Okay, again, I could cut that in half and cut it in half again to go from 8 to 4, 12 to 6. Okay, you could go that way as well. All right, and you can try number 10 on your own as well. Okay, this one's just a little bit different. Adam solved 12 math problems in 42 minutes. Okay, so 12 problems in 42 minutes. And I'm trying to figure out how long it will take to solve 20 math problems. So eventually I want to figure out, okay, so 20 math problems, how many minutes will it take? Okay, so 12 problems takes 42 minutes. Well, let's figure out how many. Let's scale this down maybe a little bit, and then maybe we can scale it up to help us out. So 12, I'm going to take this down to 6. All right, so 6 problems will take 21 minutes. 4 problems, oops, not 4, 3 problems will take 10 and a half minutes. And then I'm going to divide this by 3 to figure out how many we'll do in 1 minute. And 10 and a half divided by 3 is going to be 3.5 minutes. Okay. Now, if he spends 3.5 minutes per one problem, I am going to multiply that. Remember our scaling up where we can multiply by the number we're looking for? I'm going to do the same thing here. I'm going to multiply by 20 to figure this out. And 3.5 times 20 is 70. It's going to take him 70 minutes, an hour and 10 minutes to solve 20 math problems. Okay, so we had to do some scaling down and some scaling up. Okay, one thing, how you choose to do this might look different. So for instance, from the beginning, I might have divided by 6 here to figure out, okay, so for two math problems, 42 divided by 6 is going to be 7. You're going to get 7 math problems done every, or sorry, 2 math problems done every 7 minutes. So we'd multiply that by 10 here to get 70. Okay, so that's just another way to solve that same problem. All right, let's do another one like that. Okay, an ice cream shop sells 2 scoops of ice cream for $6. So 2 scoops for $6. What would the cost for 9 scoops be? Okay, so 2 scoops is $6. How many for 9? So I'm going to go down and figure out, okay, how much for 1 scoop of ice cream? That's going to be 3 because 2 divided by 2 is 1, so 6 divided by 2 is 3. Now I want it for 9, so I scaled down first, and now I'm going to scale up. I'm going to multiply by 9 and multiply by 9. I get 9 scoops of ice cream is going to cost me $27. 9 scoops of ice cream is $27. All right. One other way to do this one would be you could scale up and say 4 scoops cost $12, 6 scoops cost $18, 8 scoops $24, 10 scoops is $30, okay? And you try and figure out right in between the 8 and the 10 is 9. So if you go up 6 here, we would just go up 3 here and we would get our 27 for that in between number there. So that's one other way that you could use that table to solve. You can try numbers 12 and 14 on your own there, okay? And as well as 15 is very similar to that, okay? Let's take a look at number 16 again, just slightly more different. Jamie ran 10 laps in 30 minutes. He wants to increase the number of laps tomorrow in the same ratio. If he runs 25 laps, how many minutes will he take to finish? Okay, so we've got laps, we've got minutes, 10 laps in 30 minutes. Okay, we're trying to figure out how many in 25. So I'm going to do that scaling up that we just talked about. And I'm going to go to 20 laps is going to be 60 minutes. 30 laps is going to be 90 minutes. So what's going to fall directly between the 60 and the 90? Okay, well, this goes up 30, so half of that, because I'm only going up half the distance, is going to be 15. So that's going to be 75. Okay, so plus 15 for every 5. All right, we can also scale that down and see that, okay, it's going to be 1 lap for every 3 minutes. And then you can take 1 times 25 and 3 times 75. All right, and there are several more just like that one that you can try on your own as well.